Alrighty, welcome to day 6. We're going to give you 2 minutes to be able to check your free response answers, and then we'll go through each of them in the worked out solutions of them and talk through them more. But so that way you know which ones you should be focusing on as we're talking about them. So we'll go ahead and we'll pause the video for 2 minutes right now so that you can check those. All right, first one was a L'Hopital's. When you sub in pi, you end up getting 0 over 0. So take derivative of the numerator and derivative of the denominator on its own. Keep in mind pi squared is a constant, so its derivative is 0. So then when you reevaluate by subbing in 0, you just get 1 over pi, so choice B. In 2, because we're going to infinity, really the biggest powers are all that matter. So really we want to look at the square root of 9x to the 4th and the x squared. Well, square root of 9x to the 4th is absolute value of 3x squared. Because x is going to infinity, the x's will be positive. So the inside will always be positive, so we just think of that as 3x squared. So we'll have 3x squared over x squared, which just gives us 3. Now, for example, in this one, if x had been going to negative infinity, when we would have done that absolute value of 3x squared, we would have gotten a negative 3x squared in the numerator, and then our limit would have gone to negative 3. Okay, that's just if it had been going to negative infinity. All right, so there are 3 places of discontinuity here. There's a vertical tangent at negative 2, there's a jump at 0, and there's a corner point at 1. So those are all places where it's those are places where the function's not differentiable. Of those, where it is continuous, you've got the vertical tangent and the corner point, so it's just the negative 2 and the 1, so choice C. So the 3 ways to not be differentiable are vertical tangent lines, discontinuities, so it could be jump, hole, or asymptote, and then any abrupt changes in slopes like corner points or cusps. Those are the ways a function can be not differentiable. 4 was a related rates problem. So we want to start out and do your volume of a sphere, take the derivative with respect to time. Now your dv dt had to put in as negative 2 pi because they said it was decreasing. Fill in the 5 for the r and get dr dt by itself to get negative 1/50th. Then start with your surface area formula for a sphere. Do your derivative with respect to time. We'll sub in the 5 again for r, sub in the dr dt that we had, which was negative 1/50th, and we end up getting the negative 4 pi over 5, which is choice A. Now, the reason they don't have the negative there is because they specified in the question that is the surface area that the sphere is decreasing. So they've already stated that it's going to be a decreasing amount there. That's why you don't see the negative sign. In 5, we had a slope field. So some things that stand out in their slope field, at y is negative 1, we should get back 0. So in A, when you put in negative 1 for y, you get negative x plus x, that's 0, so that's in the running. In B, when you put negative 1 in for y, you're going to get negative x minus 1. Well, that's not 0, so that's ruled out. In C, when you put negative 1 in for y, you get 0, so that's in the running. And D, there's nowhere to put in negative 1 for y, so you're not getting back 0, so that's out of the running. The other thing to notice is when x is equal to 0, we also get a slope of 0. So in the first one, we would get 0 plus 0, so that checks out. But in C, there's no x value, so it can't give us back 0, so that rules that one out, so it's got to be choice A. 6 was probably the hardest problem from this assignment. So here's a graph of what this piecewise function looks like. So first off, notice that it is not continuous at x equals 3. Therefore, the derivative can't exist at x equals 3. So that rules out choice 3. And as a result, rules out choice D there. Now, what these other two things are saying is your point at 3. So that closed circle down on the bottom. We want to take points from choice 1 that are a little bit to the left of that. And then this is our slope setup. This is a change in y over a change in x, really. And we want to see, do those slopes approach 2? In choice 2, it's take points a little to the right of that closed circle and see as the point gets closer, do those slopes approach 2? So I'm going to start with a point right here. And this is choice 1 that we're looking at, by the way, because we're a little bit to the left. So there's that first one. So think about roughly what that slope is. There's our next one. Think about what that slope is. There's our next one. So as that blue point gets closer and closer to x equals -3 on the left of it, are those slopes going to approach 2? Well, hopefully you can conclude that they're not going to approach 2 because they're always going to be negative. So that rules out this choice here. So let's look at our other ones. Let's pick points a little to the right. Well, if I connect those to the closed circle, that slope is 2. If I pick something closer, that slope is 2. That slope will always be 2 as we get closer from the right, so therefore choice 2 does work out. And that's a pretty hard question. In 7, when you're taking the derivative of an integral that has an algebraic expression on top, we just sub that algebraic expression in for t and then multiply afterwards by its derivative. So we subbed in the x cubed for t and then multiplied afterwards by 3x squared. Well, then we want to evaluate at x equals 2, so you just fill in the 2 for x, and that ends up matching with choice D. In 8, our limit definition of the integral. First off, we want to find what our width of each interval is. And we do that by doing b minus a over n. And that's what this number at the end is. That's like the base of each of our rectangles from a Riemann sum. So we have 5 minus 3 over n, so that's 2 over n. So that rules out choices A and C. And then for the other part, you're always subbing in your function a plus your delta x, which is your width, times k. So for us, we're going to be subbing into our function. We're going to have f of 3 plus 2 over n times k. Well, our function was x to the 4th. So we're going to sub 3 plus 2 over n times k into x to the 4th, and that gives us choice D. Average value of a function, you do 1 over b minus a. So 1 over 4 minus -4 gives us 1/8 out front. And then we just do the integral of the function. Well, integral of the function is just the area under the curve. So you're just finding those areas there from -4 to 4. You got rectangles, triangles that you can do. And we end up getting 3/16. In 10, notice if we divided that y over, we get dy dt over y equals k. Well, this is showing us a key phrase we saw in this unit, that if the rate of change of the function is proportional to the original function. That we saw was always exponential. So the shortcut way to do this differential equation is to jump right here, that we know the solution must be in the form c times e to the kt. Well, then you can just fill in 0, 4 to find what c is. And then you can fill in the 2, 12 to find what k is, and you've got your equation then. Now the long way is what I showed on the left there. You could move y's to the left, t's to the right, do your integral of both sides, go through, find c, do all that stuff. Remember, you always resolve absolute values and plus or minuses with your initial conditions that you're subbing in. In 11, this is a derivative graph they gave us. So negative derivative should lead to negative slope, positive derivative to positive slope, negative derivative back to negative slope. So we're looking for negative slope, positive slope all in there, and then negative slope. Now, notice the derivative is existing everywhere, meaning the original function must have been continuous. So therefore, those are ruled out, okay, because there's points for the actual derivative everywhere. Now, our second derivative would have a couple spots where the second derivative doesn't exist because of the corner points in the first derivative, but our original must be continuous everywhere. So in the resulting choices, A and B, we're just looking for one that goes negative slope, positive slope for a while, and then back to negative slope, so that's choice A. In 12, you're just using your calculator. They gave you the derivative graph. When the derivative is negative, the original is decreasing, so just see which of those sets of intervals the derivative was negative. That would have matched with choice A. In 13, if we've got h prime, that's a rate of change. It's occurring at 5 minutes. And the rate of change that is occurring is the temperature is a positive 2, so it's going up by 2. So we're looking for a choice that's talking about the rate of change of the temperature being 2 degrees Fahrenheit at 5 minutes. And that is what they show us in choice D. 14 is an accumulation function. Or sorry, 15 is the accumulation function. I'm getting ahead of myself. 14, we want to recognize because f of A is equal to f of B. We've got continuous on a closed interval. This is Rolle's theorem. The other thing we need for Rolle's theorem is we've got to be differentiable on the open interval. So therefore, that's choice C. For 15, this is an accumulation function. They gave us a starting point at 1 hour, and it was 0.75 feet. And we want to go to 2 hours. So the 0.75 should go out front. We've got our accumulated then from 1 to 2 using our integral. And the inside there is just your rate function. And then this is the calculator section, so you're just putting that all in the calculator and seeing which choice to get back, which in this case was D. All right, in 16, they gave us the acceleration function, and they told us that at the moment we brake, we're 80 meters per second for our velocity. So v0 is equal to 80. So do your antiderivative of the acceleration and sub in our 0.080 to get our velocity function, which was this. The velocity function, then when you graph it, you want to see when does that velocity first hit 0. And it ends up being at this time here, this 3.3386 and change. On that interval from 0 to 3.3386, the velocity is always positive. So you don't have to worry about the fact of all of the car going in different directions. So we can simply just do an integral of that velocity function from 0 to 3.33 and change to tell us how far the car traveled, and it ends up being choice B. All right, on to the free response. So the first one, we had our volume of our cone, and we want to find the rate of change of the volume with respect to time. So do your derivative with respect to time. H we were looking at was 25. And then to get our dH dt, we use our rate function that they give us and just fill in the time we were looking at. We were working with t equals 0, so just put 0 in for all the t's in h prime, and that gives you your dH dt. Punch that all in. They said we had to have units on it. It was a change in volume, so it was meters cubed per hour. In B, we wanted to find our absolute minimum, I think it was. Yep. So we need to look at our relative minimums and our endpoints. So if you graph the h prime of t, you can find where it has a 0, and at that 0, it is switching from negative to positive, meaning that we have a relative min at that t equals 6.26 and change, and tell y and everything like we have shown there. So then we've got to do h of 0, h of 24, because those are our endpoints, and then h of that 6.26 and change. Well, that's an accumulation function. So for the second two there, we'll have to do 25 plus our integral from 0 to the value we're looking at, and that'll tell us how much has been accumulated all together. Our smallest value then is our answer. So in this case, it's the 16.339 meters. 17 is And the last one, we have a linear approximation, and we're doing it at t equals 16. So to find our y value at 16, we've got to do an accumulation function, which that's what we're doing here. We started at 25, do the integral of 0 to 16 of that rate function. So that 23 and change is our y value. Sub in 16 to our h prime to get the slope value. So here's that y, here's the slope, and here's the t value of 16. Well, we wanted to know when y was 25. And I'm treating y as the height here. So you might have had it as h's instead of y's in yours. And then get t by itself, and we get that 17.258 hours. So in our graph in number 2, we're looking where f of x, which is our derivative, switches from positive to negative, and that's where we'd have a relative max. So that's why you have x is -2. To be concave up, we want f's graph to be increasing, because that would mean that g double prime would be positive. So we have those intervals there of -1 to 1 and 2 to 3. So now we got a limit for the next one. So the bottom is going to be 0, definitely. We've just got to figure out what g of 0 is. Well, they told us that g of 3 is 7. So we're going to have to do an accumulation function to figure out what g of 0 is. And you need to have this work shown to get full credit. This is what I've got over here. So we've got 7 plus our integral from 3 to 0 is what we're looking for. Well, we want the smaller number on bottom, so we switch that to be 0 to 3 and put a minus out front. So now do your areas under the graph from 0 to 3, and you get 5 and 3. Subtract those, so we get -1. Well, now if we go back to our limit, that's going to give us -1 plus 1 in the numerator, so we get 0 over 0, which tells us to L'Hopital's. Take your derivative of each. G prime of 0 now just means our y value in the graph that's shown, which happens to be 0, so 0 over 2 is just 0. And in our last one, we're going to split that integral up separately, because the first part is going to need a u substitution. The second part is not. So this part here, you can think of it one of two ways. I thought it was just, okay, 4 is a horizontal line. From -2 to 1, it would be a base of 3. So it's just a rectangle, 3 times 4. Or you can do it with your actual subbing in and do 4x and sub in a 1 minus and then sub in a -2. The trickier part is the front part here. When we do the antiderivative of f, it's going to be g, but because we don't have just x inside, technically this is a u substitution. And this would have a correction of a half out front because of the 2x. I didn't show the u substitution. You're welcome to show it if you want, but eventually you would need to get to the fact that that 1/2 correction needed to be out front. When we sub in our 1 and our -2, when you sub in 1, you just get g of 3, which they told us was 7 in the problem. But then when you sub in the -2, we'll get g of -3, which they didn't tell us, so I did that off to the side here. We're doing another accumulation function. We got 7 plus the integral from 3 to -3. We got to flip it so the smaller one's on bottom. We got the negative out front. So do your areas from -3 to 3. We end up getting -2 for that. Calculate it all out. So we either get 51/2 or 25.5. With the time that's remaining in the period, you can start working on the day 6 homework. Have a great rest of your day.